So let's say that you have an object in equilibrium. You already know that if it is in equilibrium, it either is stopped or moving with uniform motion, that is constant speed. In other words, its acceleration must be zero. So if it is in equilibrium, you already know that the sum of all forces needs to be equal to zero. The net force needs to be equal to zero. What does this mean? This means that if you will have forces on the x direction and in the y direction, the sum of all forces pointing to your, this is your right, okay, is going to be equal to the sum of all forces pointing to your left. Similarly, the sum of all forces pointing up have to be equal to the sum of all forces pointing down. In this case, I put the diagram of a plane seen from above. So in this case, I didn't consider the weight of the plane, which would act on a direction that is perpendicular to this screen and in that direction, and the lift of the wings, which would be pointing in this direction if the plane is moving at the same altitude. So these two would cancel each other out. I'm focusing only on these forces that are horizontal. All right, so let's say that the engine has 4 turbines, each one with the same power. All right, so each one will contribute with their own force in that direction. If the plane is moving at a constant speed, then you'll know that it is in equilibrium. Then you'll know that the resultant force is zero. Then you know that the acceleration is zero. And if the acceleration is zero, this means that the sum of the forces pointing to the right have to be equal to the single force pointing to the left, which is the air resistance. Mathematically speaking, if these 4 forces are the same, I just said that they were, you would know that for F equals AR, right? Then for F minus AR equals 0. This is the resultant force, all right? The resultant force equals MA. And if this is equals 0, the mass of the plane obviously is not 0. So this means that the acceleration is 0, proving that it is in equilibrium, right? This will always happen. You don't have to prove this. You can use this as a standard result for any question that involves objects in equilibrium. You can equal, and start the question from there, you can equal the forces pointing in one direction to the sum of the forces pointing in the opposite direction. All right. If you don't have a net force 0, then in that case, you have to put the resultant force equal to mass times acceleration, the acceleration being whatever it is, either being given by the question or being the thing that you have to calculate.